So in the previous problem, you were given 3 values, right? 2 angles and 1 side. And you were asked to find all 3 of the missing values. In most situations, real-world situations, you're not going to be looking for everything. There's probably one specific thing you need to know. So let's take a look at some problems like that where you're not looking for all 3 of the missings, but a specific one of the 3. So for this, we know that Kurt Daniels wishes to measure the distance across the Gasconde River. He determines that the angle here in this diagram, labeled capital C, that this angle is 112.90 degrees, and that the angle capital A is 31.10 degrees, and that the length little b is 347.6 feet. And he wants to find the distance, the straight line distance, across the river. So he wants to know how wide that river is. So what are we looking for here?
Little a.
We want little a. That is all we care about. So we need to study this situation, and we need to figure out a way to get little a. According to the law of sines, I could get little a if I take a divided by sine of a, and I set it equal to any other side divided by the sine of that. So I know where I need to end up. I know that I'm going to start, in the end, I'm going to have little a over sine of big A. And we're going to say that it equals any other side. Well, a good side to pick is little b because I already know it, right?
Yes.
Okay. So we're going to set that equal to little b divided by sine of b. If I could fill in 3 of these 4 values, I could solve this proportion. How many of those values how many were given? It just, it didn't come out right after that preposition. Okay. How many of those values were given?
1.
Okay. All right. I was given a, right? Okay. So I know that I have a over sine of 31.10 degrees. And that has to equal little b, which I was also given, 347.6 feet over sine of capital B. So here's where I'm in trouble. In order to complete this, I need to know capital B. Is there an easy way to find capital B?
Yeah.
Yes. How could I do that?
You subtract the 31.10 and the 112.90 from 180 degrees.
Sounds great. So let's go off to the side and let's find capital B. And what does that give me?
36.
What?
36.
Exactly 36?
Yes.
36 degrees exactly. Okay? So that's what we're going to use for capital B. Once we get to here, we just cross multiply and divide. We have a sine of 36 equals 347.6 feet times the sine of 31.1. And then we will solve for A. So that computation gave us 305.463576 feet. And we need to decide what our significant digits are. It looks like it's 4. Is that right?
Yes.
So it is approximately 305.5 feet across that river. How far is that?
A lot.
It's a lot. It's like a football field, right?
Yeah.
Yeah.
Fish I could swim.
It's a pretty wide river. Make sense?
I have a question.
Okay.
If we were not to put approximate on our test, would you count off?
You mean the symbol approximate?
Yeah, the symbol.
No. It's okay. I just do it to tell the difference between before I rounded and after. So here's what we have for the next example. We have 2 ranger stations and they're located on an east-west line and they're 110 miles apart. So far here's what I know. There's a ranger station here and there's a ranger station here, and they're just saying to call this one A, this one B, and label the distance between them as 110 miles. Okay? We know there's a forest fire located on a bearing that is north and 42 degrees towards the east from the western station. So this is my western station, right? Okay, so that's north and 42 degrees to the east. So that would be about right here. And so somewhere along that line, I'm not sure where, is my forest fire. Everybody understand that? Where does the 42 go? Between the two solid lines or between the dotted and solid? Yeah. Do you know where most people made their mistake last time? They put it down here, but remember that bearing is measured from due north or due south depending on the problem. So it's what's trapped between due north and the line of sight. So this is 42 degrees. All right. Then we know that there's a bearing of north and 15 degrees to the east from the other station. So north and then 15 degrees to the east, which would rotate to the right or to the left? Clockwise, right? Yeah. So it's 15 degrees here. So there's my fire. My fire is right up there. Fire! Way up there. Is that okay? All right. Where does the 15 go? Right here. That's my 15 degrees. And I am trying to figure out how far the fire is from the western station. So I'm trying to find side little B, right? So that's how far from the western. So I want to know this length right here. All right. In order to do that, it's going to take the law of sines. I need to know angle big B to figure that out, as well as I need to know the fire angle, this angle over here. Do you guys understand that? Okay, so we need to start doing some computations, and we need to figure out what those missing angles are. Can anyone tell me what they think this angle right here has to be?
48 degrees.
48 degrees. Okay, I'll buy that. Why?
Because 48 and 48 equal 90.
Right, and so between due north and due east, there has to be a 90-degree angle, right? This much of this is how much?
90.
That's a 90-degree angle. So tell me how much this is.
105.
105, right. Okay?
So now we know.
And if we know those two things, we can find the fire angle. How much is that angle up there by the fire? 27 degrees? Because we subtracted the other two from 180. So in a real world problem, you will usually have to go in and put in things you didn't know to start with, especially your angles. That's typically what you're going to have to go find are those angles based on the drawing. Because a lot of times your angles are not inside the triangle, they're outside the triangle. So we had to go find the ones that were inside. Now all we have to do is set up a proportion that involves little b. So we have little b over the sine of 105 point. Is it point anything or is it just 105?
Just 105.
Okay, and that has to equal, which side do we know? Little c, okay, or so the fire side, okay, so we know 110 divided by the sine of its opposite angle. And then we can just cross multiply and solve for little b. So we all got 234.039789 miles. And the problem said to round to the nearest 10 miles, right? Which is, even if we did sig figs, that's where we would round anyway. What does that round to? 230 miles. Be sure you pay attention to directions. If you're not told what to round to, use sig figs. But if you're told, you have to do that instead. Make sense?